Unit 3, Section 1. Well, we're starting the brand new unit, which is on absolute value. Well, absolute value is distance from 0. And so to calculate absolute value, you basically make the number positive. So if we have the parent function, it's always going to be positive. So if I plug in -3 for x, the absolute value of -3 is how far is -3 from 0? It's 3 units away. How far is -2 from 0? It's 2 units away. How far is -1 from 0? 1. Well, 0 is 0 units away. 1 is still 1 unit away. 2 is 2 units away. And 3 is 3 units away. So hopefully you remember what that parent function looks like. It is the V shape that touched 0, had a domain of all real numbers, and then had a slope of 1 or -1, depending on if you're on the positive x values, the negative x values. So what are the slopes of the line? We just talked about that. They were either positive or -1. The center, the vertex of this graph was at the origin, 0, 0. The domain went left forever and right forever and everything in between, so it was all real numbers. But the range was only above the x-axis, or 0 at the x-axis and above, so 0 to infinity with the bracket on 0. Infinity never gets a bracket. Now we want to talk about transformations. If I said take all those numbers and add 2 to them, the y values are going to go up 2. So all you're doing is moving it up 2, which we've talked about transformations, so this should be a review part. If I subtracted 5 from all the y values, the entire graph just moves down 5. Well, if I put a +3 inside there, to make it 0, what +3 makes 0? Well, that's -3, so it moved left 3. And if that's x minus 4, went right 4. What minus 4 makes 0? Well, +4, so it went to the right. Then let's scroll. So let's see. A 2 out front is going to give it a vertical stretch of 2. So it's going to make it skinnier. So I don't know which answer, vertical stretch or skinnier. Skinnier, and it's vertical stretch of 2, which means the slope is now up 2 over 1, and it's positive or negative because we have a negative slope, positive or -2. If it's a -2, it's reflected over the x-axis. So I did not leave. So it's still a vertical stretch and it's reflected over the x-axis. So it's still skinnier, which means you went up 2 over 1 instead of up 1 over 1. So it's reflected and skinnier, and vertical stretch of 2. Vertical stretch of 2. So the slope is still positive or -2. We're just upside down, so it's doing +2 here, -2 here. If it's on the inside, well, that is a horizontal compression by a factor of 1/2, which means if you horizontally compress it, it's still going to look skinnier. So it's still skinny, and that means the slope was still up and down, up 2 over 1. Because that's the horizontal we want to talk about. We usually look at the vertical. If there's a 1/3 out front, that one is a vertical compression, which means it looks fatter or wider. And the slope would be positive and negative 1/3. And same thing on this one. The vertical compression, which means wider, it's of 1/4, and the slope would be positive and negative 1/4. There's always a positive and a negative because you have a positive slope and a negative slope, and for an upside down one, a positive slope and a negative slope. Now, a 2/3, that is a horizontal stretch, and the slope is still 2/3, but it's positive and negative, so the slope doesn't change. Let's make sure. And a horizontal stretch will look flatter or wider. So vertical compression, wider, flatter, they use those 2 words. So we want to make sure we talk about all the different flatter, wider, skinnier, all those different terms. So now let's put all those together. If it's 2x minus 4, this one, if you were to graph this, and I'm trying to think if we were supposed to graph these by hand or by using a technology. If you were to graph this with technology, Like this one, what makes 0? 2x minus 4 equals 0. You get 2x equals 4, or x equals 2. The vertex only moved right 2. So it moved right 2, which meant the slope was the number in front of the x, which was positive and negative 2. So what you have to do on that one is you have to take this term divided by this term, 4 divided by 2, to figure out what the transformation is. And 4 divided by 2, well, a negative 4 divided by 2 is a negative 2, which meant it right 2. This one, if we take 6 divided by 3, you get a positive 2, which meant this went left 2. And then the slope was the number with the x. The slope is positive and negative 3. Okay, so this is all the stuff we've talked about before. If a is less than 0, it's reflected over the x-axis. If a is bigger than 1, it's a vertical stretch. If a is smaller than 1, it's a vertical compression. If b is bigger than 1, it's a horizontal compression. And if b is smaller than 1, it's a horizontal stretch. And this, we have to go right. If it's a minus, it's going to go right. If it goes right, h over b units. And this is left h over b units. And this one's up k, and this one's down k. So let me give you those values all filled in. So there are those same values all filled in with Whitcamp's prettier handwriting than mine. So if you need to, pause the screen, but those are the same things we just talked about, but now you have actually all written on the screen. So pause this and write those down, and then come back, and when you're ready to continue, we're going to go on to the next part of the video. So for the next part now, we want to do, oops, I moved the screen, sorry. Let me fix that. We want to use the transformation of absolute values to sketch the graph. So I'm going to real lightly, let me leave this back where I wanted it so I can get to my pen, real lightly make the parent function. Parent function would have been, and I wanted this in a real light color because this is not what it looks like after it's transformed. This is before. So here's what it looked like originally. So there's the parent function. So I'm going to use red, I guess, for this one. So this one, I know it's going to go up 2 because of that value right there. And it's going to go right 3 because of that value right there. So right 3 and up 2. So take the vertex, go right 1, 2, 3, and up 2. There's my new vertex. The slope did not change, so it's still going to go up 1 over 1 each direction. And then there's your new absolute value graph. There's what it looks like now. So for the next one, for G, I don't know why. These were supposed to be boxed in, but on the screen they're not showing up boxed in. On G, this one went down 4. It went left 1. Let's plot that. So here was the original vertex, was the origin. So if I go left 1 and down 4, 1, 2, 3, 4, there's the new vertex. Now I know it's reflected because it's negative. So reflected over the x-axis, reflected over x-axis, which means flipped upside down. And it also has a vertical compression of 1/2. Vertical comp of 1/2, which means the slope is 1/2 now. But we're going down instead of up. So down 1 over 2, down 1 over 2, down 1 over 2 that way, down 1 over 2 that way, and then there's our graph. Oh, I've been filling all these in. I didn't fill it in here. We talked about it. This one was right 3 and up 2. The new center, the new vertex was 3, 2. This one, the new vertex was, we went left 1 and down 4 would be -1, -4. And then we talked about all the transformation. All the transformations were these 4 things we put up here. Or 1, 2, 3, what did I say? Left. All those different there's 1, 2, 3, 4. Reflected over the x-axis, vertical compression, left 1, down 4. Okay, let me fill it in the correct spot. So on the third one here, on H, this one went down 2. I'm going to start there. And it went 8 over 4 is 2, and it's a negative, so it went right 8 over 4, so right 2. So right 2 and down 2, there's our new vertex. And let's see, what else do we know? There is a horizontal, because this number in front of the x is bigger than 1. It's a horizontal compression of 1/4, which means the slope is 1/4. No, the slope is this number, sorry. The slope is this number, which is 4. And so we got our slope is 4. So up 1, 2, 3, 4 over 1, up 1, 2, 3, 4 over 1, and same thing the other way. And hey, I see the y-intercept. Sorry for my, oops, I'm touching where I don't need to be touching the screen. Okay. Let's move on to the next set. This one's the other way around. We already have the picture drawn. So the center was left 1. So we know this one went left 1, and it went up 2. The slope is still 1, so there's no stretch or any compression or anything. So the center was -1, 2. And that's all we had to do on that one. Oh, we got to write the function. The function for this one would be f of x equals, it's an absolute value without a stretch, went left 1, so that means a minus goes right, so a +1, and we went up 2, so +2. For the next one, this one, I notice there is a vertical stretch of 2. You can't tell horizontal from the graph. You can always get vertical. It could be one or the other, and we're always going to go with vertical. So this one went right 3. It went down 1. And a vertical stretch of the slope was up 1, 2 over 1. So vertical stretch of 2. So the center was 3, -2. So the equation, whatever variable you want to use, I'm going to use f of x equals. We had a vertical stretch of 2, so I'm going to put a 2 out front. Went right 3, and then down, what did I say, down 2, so down 2, so -2. And there's that graph. The third one, I notice it's reflected over the x-axis. It's flipped upside down, reflected over x-axis. It went right 1, went up 3. So there's my center was 1, 3, and the slope was down 1 over 1. So yeah, just a -1. So the equation for this one, f of x, or whatever letter you want to use, we said we have to be a negative, but the slope was still 1, so there's no other value there. Right 1 to be x minus 1, and then up 3 is +3. Okay, last one for this lesson wants us to use the graph to solve. So the graph, absolute value of x minus 3 plus 2 is already there. We don't have to do anything to that unless graph it if it wasn't given, but it is. Where does the graph equal 6? So let me go up 1, 2, 3, 4, 5, 6. When is y 6? Well, one of those x numbers was -1, and when the other one was x equals 7. The next version of that question says, when is the graph equal to 2? So when is the y value at 2? Well, there is one time that happens, and that's at x equals 3. Well, when is this graph ever equal to -2? That's not possible. It never equals that. That's all you have to do on those kind of. The next lesson, we're getting into actually how to solve them without a graph, but pay attention to how many answers there were. There were usually 2. Well, most of the time there were 2 answers. Any y value that's above the vertex, there's 2 answers. At the vertex is 1, and there's sometimes where that never exists at all. So that's good to know for the next lesson. That's everything you need for this lesson, so good luck to you.